Okay, good evening. Well, we're at a little early start today. Of course, we see the glare from the computer screen right there. Yes, we are at a little bit early start today, and hopefully we'll get through the entire thing today. So, we'll be continuing with our transpositional formulae, and of course, we are at the homework section. Since I'm going to be working out every single one of them on the board, then you do not need your instructional manual at the moment, but let me just tell you, here it is in the instructional manual. It's the homework for transpositional formulae, and it is on page 24 in your algebra instructional manual. This is for you. This is for you. So, algebra instructional manual, and we are at page 24. Let's begin. So, number one, we have there as s is equal to pi dn. S is equal to pi dn. S is equal to pi dn for n. Now, we are attempting to make n the subject of the formula, and it is accompanied by pi d on the left-hand side. Well, the right-hand side. Let's go again. We intend to make n the subject of the formula, and it is accompanied by pi d on the right-hand side. We therefore need to eliminate pi d. Pi d is multiplying n. Because they are in a multiplication relationship, that means we are going to eliminate pi d by division. So we'll divide both sides by pi d. When we divide the right-hand side by pi d will be cancelled, eliminated, and we just have n. And of course, on the left-hand side, we'll have s over pi d. Do not forget that your equal sign is not two-sided, because it is one-sided. And of course, because we are attempting to make n the subject of the formula, the best thing is to have your n occurring on the left-hand side, then we have over pi d on the right-hand side. 2. So the next one, a is equal to pi rl for L. Pi rl for L. Pi rl for L. Of course, number 2 is analogous to number 1. So the same steps that we take in number 2, we'll take the same steps that we have taken in number 1. Number 2 is analogous to number 1. So we have L being accompanied by pi r on the right-hand side by multiplication. We will eliminate pi r by division. Dividing both sides by pi r will be eliminated from the right-hand side, and on the left-hand side we have a over pi r. Therefore, L is equal to a over pi r. So numbers 1 and 2 are analogous, and we may use the same method to solve both of them. As a matter of fact, number 3 is also analogous to the first 2. However, it's just the position of the r, which is the proposed subject, in the formula. That's the only difference. And of course, we know that it does not affect the logic. So I is equal to PRT, and on this occasion, we are making R the subject of the formula. And R is in the relationship with PRT, is a multiplication relationship. So we need to eliminate the PT that both of them are being multiplied. And as a matter of fact, they are multiplying the proposed subject. Therefore, we will eliminate them by division. So let's go. We will divide both sides by PT. Dividing both sides by PT. On the right hand side, the PT will cancel and we have R. On the left hand side, we have I over PT. And of course, rewrite the expression with R. On the left hand side, we have R is equal to I over PT. Number 4, what do we have there? I is equal to E over R for R. I is equal to E over R, and we are attempting to make R the subject of the formula once more. Now, students, imagine that we cannot eliminate. They imagine that we cannot eliminate the proposed subject. Of course, you may eliminate anything, because as a matter of fact, anything that you eliminate from one side of the equation will somehow appear on the other. So, we may attempt to eliminate the proposed subject, which is R, on this occasion, especially that it is in the denominator. Right? We should be keen on manipulating denominators in our favor. We are dividing by R on this right-hand side. Of course, that's the proposed subject. Because it's in the denominator, we may go straight ahead and eliminate it from the right-hand side. It is being divided on the right-hand side. So we have E divided by R. We are eliminating the R, which is in the denominator. That means E is being divided by R. And because of that, we will eliminate R by multiplying by R. So when we multiply by R, it is eliminated from the right-hand side. And we also multiply by R on the left-hand side, so we have IR. And of course, we may go straight ahead and eliminate the I now that we have right there accompanying R on the left-hand side. So I is multiplying R. Because it's in the multiplication relationship, we may eliminate I by dividing by I. And we will divide by I on the right-hand side also. And that's all there is to it. Number 5. For T, P is equal to RT over V for T. P is equal to RT over V, and we are attempting to make T the subject of the formula. Now, when solving problems, especially in a practice session or homework session, it is important that we pay attention to every problem. Because this is not like in an examination when each problem will be of a one-off nature. When we are practicing, we might encounter problems that it would be very beneficial to us if we pay attention to every single one of them. Because at some point, we should get problems that are analogous to each other. So P is equal to RT over V for number 5, and we are attempting to make T the subject of the formula. T the subject of the formula. We will eliminate R and V. As a matter of fact, we may eliminate them all at once. However, let us take a one at a time approach on this occasion. That being the case, we have RT over V. Now, we need to eliminate the R. We also need to eliminate the V. Now, we will generally eliminate the one that is least related to the proposed subject first. Of course, the V is related to the T to a lesser extent than the R. The R has a more intimate relationship with the T. We eliminate the V first. Or we are saying that the V is logically at a greater distance from T than R. So we eliminate V first. We are dividing by V. Because we are dividing by V, we will eliminate V by multiplication. We are dividing by V, we will eliminate V by multiplication. We will multiply both sides by V. When we multiply the right-hand side by V, the V is eliminated. When we multiply the left-hand side by V, we have PV. And take note that I'm very careful not to say that we multiply or divide the other side or one side. Because when we are solving an equation or changing the subject of the formula, we need to do the same thing to both sides. So it is on both sides that we do our manipulation. Finally, R is related to T on that right-hand side, and it is related to T by multiplication. We will eliminate the R by division. And of course, we are going to be dividing by R, and we're going to do that on both sides. When we divide the right-hand side by R, it is eliminated and we have T left. When we divide the right-hand side left-hand side by R, we have it occurring on that side. So T is equal to PV over R. Number 6, I'm attempting to place number 6 right there. H is equal to JH over J. Of course, capital H is equal to common J, common H over capital J. And what do we do first? Because this problem is analogous to the first one, we may solve it by taking the same steps. We are making common H the subject of the formula on this occasion. What do we do first? Hj, we multiply both sides by J, we have JH. So, multiplying both sides by J, the J, which is the capital J, is eliminated from the right-hand side, and on the left-hand side we have JH. Then we are making common H, the subject of the formula. We have JH, and of course we divide by J, by common J, and that is equal to H. Finish up by saying H. Do not forget that we are operating on the premise that this problem number 6 is analogous to problem number 5. So because they are analogous to each other, we may take similar steps. Sometimes when we are solving a problem, the analogy does not go straight through. Right? So you might find occasions on which the analogy does not go straight through. When the analogy does not go straight through, then of course we make a difference at that point. But as long as the analogy holds, we continue to do the same thing. It's a perfect, legitimate problem-solving method, that is solving by analogy, and students may use that as often as you please, without consequence. Number 7. It looks very cumbersome, but you know that this is a simple problem. V is equal to pi d squared h over j, and we are attempting to make h the subject of the formula. As a matter of fact, this one is analogous to both 5 and 6. We will make h the subject of the formula. The one that is least related to the proposed subject is j right here, j that we are dividing by. We will eliminate j that we are dividing by multiplying by j. And we'll do that on the other side also. When we multiply the right hand side by j, j will be eliminated. And on the other side, we also multiply by j, we have vj. All that we need to do is eliminate pi d squared. It might look a little bit cumbersome, but there's nothing much to it. All of these are multiplying by h. They are multiplying h, the proposed subject. Because they are multiplying h, this proposed subject, we will eliminate them by dividing. Or we'll say by division. So we divide the right-hand side by pi d squared. And we are going to divide the left-hand side by pi d squared also. What we do to change one side of an equation, we will do to change the other side in the same way. And of course, you will see occurrences or you will see occasions on which we only change one side and we do not change the other. We will change one side and not change the other if we are only changing the form on that side. For example, when we are factorizing. When we factorize one side of a formula or equation, we are not changing its value. We are just writing it in another form. In that case, the other side is not affected. So we don't have to do that on both sides, because most of the time, you will not be able to factorize the other side anyway. So only if it affects the value on one side, then we need to do that on the other side also. So we will eliminate pi d squared, that is multiplying the proposed subject, and we are going to do that by division. When we divide by pi d squared, they will be eliminated from the right-hand side, and of course, on the left-hand side, we have vj divided by pi d squared. Then, all we need to do is turn the beat around vj over pi d squared. Number 8. Your favorite is coming up. V is equal to u plus at for t. V is equal to u plus at for t. That's one of your favorite. We need to make t the subject of the formula, and we are cumbered by u and a. So we need to eliminate the u, we need to eliminate the a. What do? We eliminate the 1 I say good evening, sir. I'm saying good evening, sir, to you too. So we need to eliminate the u and we need to eliminate the a. First, we eliminate the one that is least related to the proposed subject. The one that is least related to the proposed subject is u. Seemed somewhat detached. We will eliminate the u, which is, of course, in an addition relationship. And when I say addition, it is for you to understand at this stage that subtraction is also included. Because you learned earlier that subtraction is merely adding in the negative direction. So addition and subtraction should be categorized in the same way. You know that from directed numbers that both of them are actual addition, but the plus one adds in the positive direction and the negative one adds in the negative direction, or the minus one adds in the negative direction. So this is an addition relationship that we have here. The u, of course, this sign is not pertaining to the u. This sign is not pertaining to the u at all. The sign that is pertaining to the u is the one that we do not see. Is the one that is before the u. And you know that when it is not accompanied by the sign, then the sign is a positive sign. So it is a positive u here that we need to eliminate. And we'll eliminate that positive u by subtraction. And of course, we will subtract on both sides, therefore. We subtract on the right-hand side in order to eliminate the u. And on the left-hand side, we subtract in order to balance the equation. We finish up by eliminating a that is in a multiplication relationship with t. Because it's being multiplied, we will divide by a. And we do that on the other side also. Dividing the right-hand side by a, the a will be eliminated. And the left-hand side, we'll have v minus u. We need to divide by a also. So t is equal to v minus u over a. Number 9. This one is analogous to number 8. X is equal to uv, x is equal to uw plus v. X is equal to uw plus, x is equal to uw plus v. It's just the order of the terms, just the order alone is different. But it is in perfect analogy with number 8. We need to make u, I think, the subject of the formula. No, it's w on this occasion. We need to make w the subject of the formula. It is accompanied by v and u. To a lesser extent, it's related to the v. So we'll eliminate v first because it is the one that is least related to the proposed subject. And we can blatantly see on this occasion that it is being added. So because it is being added, we will subtract. So we will subtract v from the right-hand side, thereby eliminating v, and on the left-hand side, we minus v right there. Attempting to make w the subject of the formula, and of course we can plainly see that the w is accompanied by u by multiplication. Because it's being multiplied, I see someone saying good night. Good night to you too. Right. So this w that we are attempting to make the subject of the formula is accompanied by u. And it's accompanied by u by multiplication. We will eliminate that u by division. So we'll divide on the right-hand side. We'll divide the right-hand side by u. By so doing, the u will be eliminated. And we also need to divide the other side by u. So that is our result, x minus v over u. Finish up by writing the proposed subject on the left-hand side. Number 10 is also analogous. R is equal to m plus pt for t. Of course, we will eliminate this m by subtraction, just like we have done in the previous two. So we'll not invent the wheel. And then we'll divide both sides by p, thereby eliminating the p. So we'll not take an hour on this one because it is in perfect analogy to the previous two. T is equal to r minus m over p. And that's all there is to it. Number 11 for A. Surely, number 11 is analogous to numbers 10, 9, and 8. But what do we notice? We notice that for number 11, we notice that the proposed subject, which is A, so let me write that A is equal to K minus 2.8A. What do we notice? We have to notice something. Mathematics is better for students who are prepared to pay attention to detail. There's a big difference there. What's the big difference? The proposed subject is present there in a negative term. Let me write it better. So A is equal to K minus 2.8A. And we are attempting to make A the subject of the formula. And it is present in a negative term. Students, sometimes what is intended, not in life, not in an exam, but in life, what is intended for a negative result or something to put you at a disadvantage, you can use it to your advantage. Yes. So this negative sign here is a blessing and not a curse. Now that the proposed subject is in a negative term, it is best if you take steps to write it in a positive term. Write it in a positive term. How do we do that? Because it is subtracted on the right-hand side, we may eliminate it from the right-hand side by addition. There is no rule that says that we cannot eliminate the proposed subject, because you know that if you eliminate it from the right-hand side, it will appear on the left-hand side in another form. And we are ensuring that the form that it occurs on the right-hand side, the form that it will appear on the left-hand side in is better for the solution of the problem, because we are going to cause it to appear in a positive term. Because if we are going to eliminate this negative 2.8a, we are going to eliminate that by addition. And of course, what we'll have when we eliminate that by addition, we have the k right there. And then we'll have a positive 2.8a on that side. Let me write it a little bit more. 2.8a. We'll have that. Now, in the same breath, because if we just add the 2.8a to both sides, we will have this a still present on the right-hand side. On the left-hand side. In the same breath, we will eliminate this positive a by subtraction. So we have minus a right there. So we eliminate the negative 2.8a from the right-hand side. We have a positive 2.8a on the left-hand side. We eliminate this positive a from the left-hand side. We have a negative a on the right-hand side. Now all that we need to do is divide both sides by 2.8. So we have k minus a over 2.8. And that's all there is to it for number 11. I'm looking closely to see if number 12 will be able to be out of the spotlight on that side. If it is narrow, maybe number 12, not number 13, but number 12. I think number 12 will be able to go there. Let me write it and then look at it. C is equal to E over C is equal to E over R plus R for E. R plus R for E. Well, it's a little bit out of it, so the students should be able to see that. No problem. Now, students, as you can see, that if we are making E the subject of the formula, all we need to do is eliminate that denominator. And we are through. So let us go straight ahead and eliminate this denominator. How do we eliminate a denominator? Because a denominator is something that we divide by. All the time when we are eliminating the denominator, we will eliminate the denominator by multiplication. So we'll eliminate the R plus R. This R plus R is dividing into E. So E is being divided by R plus R. So we need to multiply by all of R plus R on both sides. So on the right hand side, we multiply by R plus R, and the R plus R will be eliminated, the E is left. On the left hand side, we take the C and multiply by all of R plus R. Let's see how it fits outside of the spotlight, if it does. All right. And we'll finish up by writing E where it belongs as the proposed subject. Now it is the subject on the left hand side. C R plus R. And I'm always looking if it is going to be impeded by that spotlight. Number 13. Well, number 13 is a little bit wide to begin with. M is equal to L, P minus P for P. M is equal to L, P minus P. Of course, one is uppercase, one is lowercase. One is uppercase, one is lowercase, and we are attempting to make which one is subject? Uppercase. So we are attempting to make the uppercase P the subject of the formula. I see another good evening. Good evening. And I see someone, but wait. Are you in the wrong place? No, you are not. Let's continue. For uppercase P. Now, students, sometimes in life and also in mathematics, the first step that we try to take the most convenient first step. Because if you just look at this, P minus P inside of this pair of brackets, you can see very quickly, if we just eliminate the L, then of course, P minus P is the only thing that will be left on that side. And then P, the proposed subject, will be more in our grasp. It is going to be more convenient initially if we just divide both sides of the equation by L, thereby eliminating L from this side and dividing by L there. However, for the intents and purposes of the best answer presented, what should we do? I see somebody saying that we should plus P. Cannot see the L. Of course, let me cause it to look more of an uppercase P. There it is. So we have two choices. You would not go straight ahead and eliminate the P by adding P. Because you should see that we'll have a serious manipulation problem with the L multiplying the brackets right there. And of course, we can take either of two approaches. One of them is to expand the brackets, and the next one is to eliminate the L right away. So eliminating the L right away is very convenient, but in the long run, it causes the expression to look a little bit awkward. So what do we do first? First, we will expand the brackets. So we have M is equal to L capital P minus L common P. Expand the brackets first. Of course, by so doing, this P is our proposed subject. We need to eliminate this negative LP. And we'll eliminate this one that we are subtracting. We'll eliminate it by adding. So we have M plus L common P is equal to L capital P. And all that we need to do now is eliminate this L that is being multiplied. So we'll do that by division. So M plus LP, which is common P, eliminate this L that we are multiplying by dividing by L, and that is equal to P. So P is equal to M plus LP over L. And that's all there is to it for number 13. I'm doing a little measuring. Number 14. H is equal to 10 n minus common n over j for j. Well, that's not bad. It's not bad as a matter of fact. It looks to me to be somewhat awkward. We have brackets and we have a denominator. So that is more than a mouthful. But of course, when you look right through the problem, you will see that the proposed subject is in a negative term on the right-hand side. And you know that's good for you. If it is in a negative term on the right-hand side, then that's not too bad. The first thing that we do is eliminate the one that is least related to the proposed subject first, which is this j that we are dividing by. And we're going to eliminate it by multiplication. So hj is equal to 10 n minus n. And that's all there is to it for now. As I said before, we are in a position pretty much like this one, where we have a 10 preceding the pair of brackets, meaning that we are multiplying. So we may divide by 10, which is one option, and then the other option is to expand the brackets. So we should just go expand the brackets. So let us expand the brackets. Hj is equal to 10n minus 10 common n. That's what we have. And we have been here before. Students, we have been here before. If the circumstance is not unfamiliar, that means if it is familiar, then we may make the same steps. Like here, is it? Let us take a look at it. I'm sure that we had a circumstance like that quite recently. No, it is not here. Where the proposed subject is in a negative term. It is right here, that number 11. This circumstance that we have here, beginning number 11, is the exact same circumstance that we have here. Where the proposed subject is in a negative term. And what do? We eliminate the proposed subject from the right-hand side by addition. So we have 10 common n right there. And in the same breath, and I'm using the same term, in the same breath, we will eliminate hj from the left-hand side. And this, of course, is a positive hj, so we have minus hj. We have minus hj right there. And of course, we'll just finish up by dividing by n. So start by dividing by 10. So 10n minus hj, and we divide by 10, and that's all there is to it. Students, do not be afraid to solve by analogy. There are quite a few topics in your syllabus that will be easily manipulated. Couldn't see the capital L? Or the common L? Yes. Someone said that they couldn't see the L and I rewrote it. So maybe it's the same thing that we have right there. Right. So what do we do now? We'll continue, and we have 6 more to finish the 20. That's fine. And we have quite a few to do with your linear equations also. We imagine that the 6 will get more and more challenging to the end. But it's the same principle. The only principle that we have not applied so far is factorization, and we might do that before the end. Number 15. Student number 15 is light work. Why? Because if you have been paying attention all along, let me see if it is an exact analogy. No, it is not an exact analogy. So the analogy does not hold straight through to the end. Right? So, of course, there's an analogy with 15 and 14. But it does not hold true to the end because we are making uppercase, or what we call a capital M, the subject of the formula. That's right. Yes, there's an analogy between numbers 15 and 14. So let's use the analogy. Let's go. We had a denominator that we needed to eliminate, and we did that, so we're going to do it again right here. Km is equal to Rm minus T. The proposed subject is enclosed in the brackets here. We will remove the brackets. That means we'll expand the brackets, and we'll have Km is equal to Rm minus RT. And that is where your analogy ends for the moment. Additionally, we have two occurrences of the proposed subject, and they are on both sides of the equation. So we have two occurrences of the proposed subject. Now, our job, our duty, is to get them to be on the same side, and we'll go straight ahead and do that. So, we have, let's take a look at it this way. If we eliminate Rm, we'll have Km minus Rm. That would be good because all of the terms contained in the proposed subject will be on the same side, and we may go straight through. But notice that we have 1, 2, 3 terms, and we have 1, 2 negative signs. While solving the equation, or while transposing the formula, we should proceed in such a way that the negative signs do not outnumber the positives. But it's not something that we need to be too conscientious about. No, we do not have to be too conscientious about it. Now, what I'm proposing is that although it is important to get the proposed subject to be on the left-hand side and all of the terms with the proposed subject on the left-hand side, it does not hurt if we get them all to be on the right-hand side instead and everything else on the other side. So, let that remain. Eliminate Km from this side by subtraction and eliminate RT from this side by addition. A positive RT right there. So RT is equal to, now that we have more than one occurrences of the proposed subject, what do? We have more than one occurrences of the proposed subject. We just factorize, taking a common factor of m. Now we just have one occurrence, and we have r minus k. And generally, it's a what we'll call it now. I don't want to use the word that they always use, because people say, oh, let it fit into the algorithm. Students, they use a lot of words on the internet, and if you do not know what you're talking about, they'll mix your brain up. Yes, they'll mix your brain up. An algorithm is a sequence of steps used to solve a problem in a finite amount of time, and therefore a finite amount of steps. So an algorithm is a series of steps used to solve, or we would say, is a series of a finite number of steps used to solve a problem in a finite amount of time. That's what an algorithm really is. So every time it fits into the algorithm, it fits into the algorithm, it fits. We are going to be overusing that term every day because of the algorithm. I will not use that term so loosely. All right. Let's continue. So we have RT is equal to M, R minus. All we need to do is eliminate that huge factor, and we are done. And of course, if you were following the live up to the point, then you would have seen a simple procedure. More than one occurrences of the proposed subject, get them all to be on the same side. When they're on the same side, you factorize. After factorizing, you divide by the large factor. And that's all there is to it. So, RT over R minus K is equal to M. So M is equal to RT over r minus k, and we are finished. And number 16 is your favorite. U is equal to h times the square root of c for c. U is equal to h, the square root of c for c. And of course, you see what you need to eliminate there. You need to eliminate the h, and you need to eliminate the square root. And of course, by logic, h is more distant from c than the square root. And it's also physically further. Yes, it's also physically further. But we're not so taken over by physical distance as logical distance. So, of course, h is both physically and logically at a greater distance from c than the square root. We'll eliminate the one that is least related to the proposed subject, which is h, and it is being multiplied. So we'll eliminate it by division. U over h is equal to the square root of c. And of course, you know what you need to do now. You need to square both sides, thereby eliminating the square root sign on the right hand side and then squaring the left hand side. So squaring both sides, the square root sign is eliminated, and then we'll have what? U squared over h squared. Then c is equal to u squared over h squared, and that is where we end. I think that the classwork exercise was more attractive than the homework exercise. Number 17. G is equal to 2 pi the square root of x over mr, and we are attempting to make r the subject of the formula. Yes, we are attempting to make r the subject of the formula. Let's go. The first thing that we eliminated, and I'm not solving just by the logic alone. I'm also solving by analogy, because you had, for your introductory set of problems, yes, what we'll call it now, not your activities, the illustrations, the examples, you had a problem like this. And of course, in the classwork, you had problems like these. So we may solve by analogy to some extent, to all extents. So what do we do first? We eliminate the 2 pi, yes, by division. It is being multiplied here, so g over 2 pi is equal to the square root of x over mr. And of course, we know what to do next. We go straight ahead and eliminate the square root by squaring both sides. So the left-hand side will be squared, g squared, and of course, do not forget to square the 2, because some students will forget to square the 2. And that is equal to x over mr. And I'm taking as much as I can from this problem being analogous to problems that we solve both in the illustrations and the classwork. The proposed subject is in the denominator. We can do either of two things. We can multiply by mr, or we can reciprocate both fractions. And we know that if we have two fractions that are equal, when we reciprocate them, they are still equal. It is more sensible to do the reciprocal than to just multiply by mr on that side, because it looks like when we multiply by mr, we will have it entangled with g squared 4 pi squared, and do not forget that we are carrying the r with it also. So what we'll do the reciprocal. 4 pi squared over g squared is equal to what? mr over x. And we'll eliminate now the x that is being divided, which is least related to it, to the proposed subject. We'll eliminate that x by multiplication. 4 pi squared x is equal to mr. Then we will eliminate the r. Is it the r? No, the m. We are making r the subject of the formula. Eliminate this m that is multiplied. So we have 4 pi squared x over m is equal to r. And we finish by saying r is equal to 4 pi squared x over m, which is quite a bit. Don't worry. It is nothing to be afraid of. Do not forget that what we did was what? Divide by 2 pi as usual. Eliminate the square root side as usual. Reciprocate the fraction as usual. And then, of course, in the last few steps, what do? Eliminate this x that we are dividing by, we multiply by x. Eliminate this m that we are multiplying by, we divide by m. And that's all there is to it. It's a nice and smooth experience right there. Number 18. For y. Students, learn to look right through your problem. You see two occurrences of the proposed subject. You imagine that you will have to factorize in the end. And you know that if you factorize in the end, you're going to divide by the large factor. So learn to see through your problems. The square root, eliminating the square root by squaring is out of the question, because it follows directly from what we have just done. So there's no difficulty there. So let's do number 18. We have more than one occurrence of the proposed subject. We must imagine that at some point we are going to factorize. No problem. So number 18, q is equal to the square root of y over x plus y. No problem with that whatsoever. You know that the first thing that you're going to do is eliminate the square root by squaring. So we have q squared is equal to y over x plus y. And you know what we are going to do. We are going to flatten the equation. That's a term that we use. We are going to flatten the equation. That means we are going to put the equation in a certain form that has no denominator. So we're going to flatten that equation. How do we flatten the equation? By eliminating the denominator. How do we eliminate a denominator? By multiplication. So what I'm going to do, students, I'm going to show you a proposed step. So I'm not going to do it. And I think that we would have understood this from the class exercise. We take the q, eliminate the x plus y by multiplication, x plus y there, and that is equal to y. But this step is a waste of time and space, because you know that if you include the brackets there with the proposed subject inside there, you will eventually have to expand it. You know that, yes, you know that you will eventually have to expand it. So why not expand it in the meantime? So while multiplying by the denominator, instead of putting brackets, we're going to say q squared times x gives you q squared x. plus q squared times y gives you q squared y. And then this now is a regulation problem with occurrences of the proposed subject on both sides. You know exactly what to do. Q squared x is equal to y plus q squared y. You know what to do. And then what do we do next? We have two occurrences of the proposed subject. We know that we are going to factorize 1 plus q squared. And of course, after we factorize, you know that we are going to divide by the large factor. Q squared x over 1 plus q squared is equal to y. So y is equal to q squared x over 1 plus q squared. That's nice. Very nice. I'm going to use a marker that I think might be brighter than that one. For number 19. Time for number 19. I'm looking ready. It's some distance away. Yes, it's some distance away. Number 19. What do we have? G is equal to 3 over 4k plus 5. And we are attempting to make k, there's only k to make the subject of the formula. We cannot make 3, we cannot make 4, and we cannot make 5 the subject of the formula. So k is the only thing that we need to make this subject of the formula. And here we have again familiar circumstance. What is that familiar circumstance? Let me see if I can find it somewhere on the board. Would we say this is about right here? Yes. We're dividing by something like this. So instead of just putting the g and enclosing 4k plus 5 in brackets, we do it in one step. So we're going to multiply this by the g, and we have what? 4kg plus 5g is equal to 3. And attempting to make k the subject of the formula, we eliminate the 5g that is being added there. So we subtract the 5g. And of course, in order to make k the subject of the formula, we will eliminate both 4 and g that are in a relationship, a multiplication relationship with k. So we'll eliminate them by division. So k is equal to 3 minus 5g over 4g. And that's all there is to it. And your favorite is coming up. Number 20. It's your favorite because of two things. One, it is the last one. And maybe of how cumbersome it is. Let's go. Students, you have to proceed by concept, by principle, and do not leave your foundation. Look at number 20. If you see number 20, it looks awful. Surely looks awful to me. B is equal to 2 open bracket m minus zx all over x x minus 1, and you are attempting to make what? Z the subject of the formula, students. Students, this problem is not difficult. It is only cumbersome, but it's not difficult. Because you know that we are dividing by this, so we need to eliminate it by multiplying there. So let's go and multiply. So this is going to multiply all of this. So we'll have b. So we'll have the b times the x, bx, open bracket, x minus 1. Students, the proposed subject is enclosed in these pair of brackets. You know that you will have to expand. Don't do it in the next step. Do it in this very same step. So after eliminating the x times x minus 1 that we are dividing by, we eliminate that by multiplication. Let us expand the brackets. Our proposed subject, which is z, is enclosed in the brackets, and we cannot make it the proposed. Sorry, we cannot make it the subject inside there. So 2m goes there, 2m goes there, and minus 2zx. Just by looking at this, you imagine that this space could never be enough to solve this problem, just because it is cumbersome. So I hope that you have seen that all that we have done is multiply there and expand the brackets. That's all we have done. So all that we need to do, what makes the problem simple is that we only have one occurrence of the proposed subject. We just have one occurrence of the proposed subject. It's in a negative term here. Of course, when it is in a negative term on the right hand side, it is to your delight. You'll just eliminate it by addition. So you have a positive 2zx right there. And then that is equal to 2m. And in the same breath, you are going to eliminate all of this. Keep it together, you don't even have to expand it. It is not affecting the proposed subject, so you may just hold it together just as it is. Minus b times x, x minus 1. You are finished now. Making z the subject of the formula. Making z the subject of the formula, all we need to do is eliminate this 2x that we are multiplying by. So we just divide by 2x. So this subject, this particular problem that looks extremely cumbersome, that you imagine will take up the entire board 3 times. It is not so difficult after all. And what makes it simple, it is that we have what? One occurrence of the proposed subject. That's all, because we have one occurrence of the proposed subject. That's make it very simple. Well, I'm not understanding that question. But of course, we have mathematics resources for pure mathematics unit 2. We have resources for pure mathematics unit 2, no doubt. So what we will continue to do is continue the tutorial, and I'm happy that we have gone through the first part of it. Second part coming up. I hope that it is going to be shortened by the fact that you know what is 5 plus 32. No. The homework section does not have 20 problems. It has 40 problems. So you have to be extremely cooperative that we can finish this in good nick. Let's go. go. Now, it's a very good thing to have one following the other, one just after the other. Yes, it's good, Nick, that we have transposition followed by the solution of equations because they are directly related. As a matter of fact, we solve a linear equation by the process of transposition. Let's go. Let's make light work of the first $20. The first 20, they are flat. So let's go. Number 1. X plus 3 is equal to 9. X plus 3 is equal to 9. What is x equal to? X is equal to, don't tell me this minus that. Just give me the flat answer. Just give me the flat answer for that one. X is equal to? Everybody is with one foot on the ground. So I am not seeing any answer in the chat as yet. All right, maybe you'll do that. Yes, the 3 is added here. So we will subtract 3. 9 minus 3 is equal to 6. We are done. A minus 5 is less than 7. A minus 5 is less than 7. So A is less than what? No answer yet? You should be on the edge of your fingers waiting to type that. Of course, we are subtracting 5 there. We need to eliminate just the 5 in order to get the value of A. And the 5 is being subtracted, so we will add. So we add. So we have what? 7 plus 5, and that's 12. 3q is equal to 12. 3q is equal to 12. Q is equal to 3q is equal to 12. Q is equal to we are multiplying by 3 here. We will eliminate the 3 by division. So divide 12 by 3, we get 4. B minus 1 is equal to, is greater than 11. B minus 1 is greater than 11. Students, notice that we are solving inequalities also. And we are not making any big difference with the transposition. As a matter of fact, there is no difference with the transposition. If an exceptional case comes up, then I will make the exception. But let's go straight ahead. B minus 1 is greater than 11. So what do we write? B is greater than now we are subtracting 1 there. So what we'll do? Since we are subtracting 1, we will add 1. So B is greater than, I'm not seeing the answer, 12. 5. R plus 7 is equal to 4. I love this one. R plus 7 is equal to 4. So R is equal to, I'm going to be waiting forever for the answer for that one. For number 5, what is R equal to? Thank you very much. Negative 3. 4 minus 7 is negative 3. Number 5, number 6. What do we have there for number 6? 4x is equal to 16. 4x is equal to 16. What do we have for x? 4x is equal to 16. What do we have? We are multiplying by 4, so we need to eliminate that 4 by division. So x is equal to 16 divided by 4, which is 4. Number 7. M over 5 is equal to 8. M over 5 is equal to 8. What is M equal to? What is M equal to? M is being divided by 5 on that left hand side. We will eliminate the 5 by multiplication. I'm still waiting for the answer. Some students imagine that I've given up. So let me hear the answer. Not yet. One more second. Since we are dividing by 5, we will multiply by 5. So 5 8 40. Number 8. M over 3 is less than 4. M over 3 is less than 4. Let's go, students. That means what? M is less than what? M is less than, we are dividing by 3, so we'll eliminate the 3 by multiplication. No problem. For number 9, 7x plus 2 is equal to 16. Of course, we will eliminate the one that is least related to x first, which is 2. So we'll eliminate that 2 first, thereby writing what? 7x is equal to what? 7x is equal to Alright, we'll eliminate this 2 that we are adding here. We'll eliminate it by subtraction. So we'll have what? 7x is equal to 16 minus 2, and that is equal to, since no answer is forthcoming, 14. And there we have the problem involving, well, give me the next part very quickly, because you caused me to go straight ahead of you. So I imagine that you will just give me the next one exactly. We are dividing both sides by 7. The result is 2. Number 10. 8x minus 3 is greater than 13. 8x minus 3 is greater than 13. So 8x is greater than what? I'll be very delighted to see the students on their P's and Q's. So as soon as I put something on the board, 8x is greater than, of course, we are subtracting 3 here. Because we are subtracting 3 here, we need to eliminate the 3 by addition. So we'll have what? 13 plus 3. I'm not seeing that that's taking too long. So that will be equal to, let me see if I turn around and I see. No, not yet. So some students have already fallen asleep. Eight. I think that you did it wrong. Do it again very quickly. X is being multiplied by 8. X is being multiplied by 8. Therefore, we need to, what do we need to do? We need to divide both sides by 8. When we divide by 8 on the left hand side, sure 2, we get x. And divide by 8 there, we get 2. Number 11. My book is upside down. 5q minus 7 is equal to 18. 5q minus 7 is equal to 18. I know that something was wrong, you know. I know that something was definitely wrong. I know that something was 100% wrong. But now I've caught up with it. Let's go. As a matter of fact, I'm not going to do this one then. I'm going to change it. (4x plus 10 is greater than negative 2. Students, I remember doing the odd numbers of these problems, students. Yes, I remember doing the odd numbers of these problems. But no one inside the class remember that. But I remember now that I'm saying, but these problems seem so familiar. Like I've done them before. Yes, I did the odd numbers of these problems in classwork. So only the even numbers we have to do now. So let's continue. So we have 4x plus 10 is greater than negative 2. So what should we write now? 4x is greater than what? Let me see who will get that one right. Let's see who will get this one right. 4x is greater than what? Yeah, I know that something was wrong. And I just kept looking at the problem and said, no man, something wrong with this. Yeah, I saw something. There's something wrong with this. What's wrong? Negative 8 minus 10 is what? What is not negative 8? Negative 2 minus 10 is? Let's see who gets it right. Negative 2 minus 10. Negative 2 minus 10. So x is greater than what? X is greater than what? We are multiplying by 4 here, so we need to divide both sides by 4. So negative 3. Number 14. I hope number 14 will be able to hold right there. No. Yes, it can. (2x minus 3x plus 4x is equal to 18. Students, there is no transposition. Well, there is transposition, but there is not much of it to begin with. We need to put all of these together. When we put 2x minus 3x plus 4x, what is the result? No problem seeing that x is equal to 3. So those students who are disappointed that I worked number 14 out so quickly, make sure that you're on your P's and Q's for number 16, so that I will not go away from you on this occasion. 4x minus 2 is equal to 3x plus 2. I love this one. 4x minus 2 is equal to 3x plus 2. What do we do? Let's put the x's together and everything else on the other side. 4x minus 3x is equal to 2 plus 2. Finish up, because 4x minus 3x is merely x, so x is equal to 4. 18. Two x minus 11 is less than 4x. I think it's plus 5. Of course, this is an exceptional case. Yes, this one is an exceptional case. Anyway, we look at it. Let's go. All right. For those students who are in a hurry to get all of the x's on one side, you may say this. 2x minus 4x is less than 5 plus 11. So you get a negative 2x is less than 16. Yes. What do we do next? Whenever we are dividing through an equation by a negative quantity, we also need to change the inequality sign. So this is one case in which we change the inequality sign. You know that already because it was done in classwork. Yes, you forgot all of the problems that we did. All right, let's continue. So we have what? Negative 2x is less than 16. We are dividing straight through by a negative quantity. We will therefore change the inequality sign. Number 20. Number 20 looks awful, but it's actually very nice. So let's write number 20. 1.3x, 1.3x minus 0.7 is equal to 0.8x plus 1.3. It's quite wide. Number 20. So we'll do this. 1.3x minus 0.8 is equal to 1.3 plus 0.7. So what will we have? 1.3 minus 0.8x. So 1.3x minus 0.8x, that will give us what? 0.5x equals 1.3 plus that is what? 2. How many halves are in 2 wholes? If we have 2 cakes, how many halves do we have? If we have 2 cakes, how many halves do we have? Exactly. So x is equal to 4. Students, you can't cause a little circumstance to overpower you, you know. You overthrow them. That's what I say. Number 22. 8 r minus 2 is greater than or equal to that. So 8 r minus 2 greater than or equal to 24. Nice. I hope that you recognize r minus 2. I want to cause the top to be a little bit more open. Right. R minus 2. Students, it is well and good to expand these brackets and show that you can do that. But I hope that you see immediately that 8 can go into 24. And because of that, you might divide the entire equation by 8. And that is why I put it all the way down here. Because I know that the solution is short enough to be here. So let's go. Divide both sides by 8. All we have is r minus 2 is greater than or equal to 3. And then we'll just eliminate that negative 2. R is greater than or equal to R is greater than or equal to, I think, 5. Number 24. Number 24 is extremely wide. I have no problem with that one. Number 26 is not so wide, although it is wide too. So let's go with number 24. 2p plus 2. 2p plus 2 minus 4p minus 5 is equal to 28. And I'm watching it with the glare on that side. Hopefully, by the next 2 steps, it will not pass through the glare. Let's continue. What we will do is expand the brackets. 2p plus 4, 2 times p, 2p, 2 times 2 is 4, minus negative 4 times p, negative 4p, negative times negative is positive, is equal to 28. I'm trying to get it out of the glare. Yes, alright, so let's put all of the p's together. And of course, this is what we'll do. 2p minus 4p is equal to 28. We're going to eliminate this positive 4. Alright, let's put it together first so that we can do it in one and it's going to be narrow instead of wide. We have a 4 here and a 20, so that's 24. So we're going to eliminate 24 just by subtracting 24. That's better. And of course we have what? Negative 2p is equal to 4. So p is equal to, divided by negative 2, negative 2. 26. I'm sure that number 26 will pass right under the glare. Let's see. Yes, it will. Yes, number 26 will pass under the glare. So we have what? Oh no, number 28 will not pass anywhere. So let's go. Number 26. 4 r minus 3 is equal to 12 minus 5, 3 minus 2r. Nice. Number 26 is extremely wide for no reason. Well, it's surely not hard. Let's continue. Expand the brackets. We have 4r minus 12 is equal to 12 minus 5 3 is 15. Don't forget that negative times negative is positive. 10r. What's wrong with that? Plus 10R. That's better. So we have 4R, 4 3 is 12. Then we have 12 there. Make sure that this is what we should have. 5, 3 minus 2R. That's nice. So put them all together. What do we have? 4R minus 10R is equal to 12 plus 12 minus 15. No problem. Negative 6R is equal to I think is 9. 24 minus 15. That's 9. And then what do we have? We are going to divide. But let us simplify it in the same breath. Let that take forever. Right, don't let us take forever with that one. So we're going to have what? R is equal to 3, sorry, not 3. Negative, 3 as well, negative 3 over 2. R is equal to negative 3 over 2. Number 28. It looks like a disaster to begin with, but you'll have a lot of fun. A over 3 plus A over 4. No, it's 2 first. A over 2. A over 2 plus A over 3 plus A over 4 is equal to 26 over 3. All right, let us flatten it in one breath. Multiplying by a number that 2, 3, and 4 can go into without a remainder. Come on, everybody knows that number that we're going to multiply by. What is that number that we multiply by? That is divisible by 2, 3, and 4. No, not what those are divisible by. See the answer there? So we're going to multiply by 12. So 2 into 12, that is 6. 6 times A is 6A. Plus 3 into 12, that's 4. 4 times A is 4A. 4 into 12, that's 3. 3 times A is 3A. 3 into 12, that's 4. 4 times 26 is 104. So what do we have? 13A is equal to 104. Implies that A is equal to 8. Of course, if we divide 104 by 13, if we divide 104 by 13, we'll get 8. That's better. Number 30, if possible. All right. Where is the glare? The glare is right here. All right. Now, students, number 30, I'm going to put number 30 right here. And I'm going to attempt to solve it right there. But let's see if we can. X, I know what I'm going to do. I'm going to put number 30 up there and then put the problem there. So for number 30 we have x plus 2 over 3 is equal to 2 plus 3x over 4. 2 plus 3x over 4. Put them together. Don't flatten the equation or anything. Let's put them together. So we have x minus 3x over 4 is equal to 2 minus 2 over 3. Students, instead of using a programmed way of doing it, let us use our common sense. Let us use our common sense. We have x. Let us call x cake. Let us call x cake. So we have a cake, and we minus 3/4 of the cake. What do we have left? That's a problem. That's a question for you. We have a cake. Not 30, is 30. We have a cake, and we minus 3/4 of the cake. What's left? Anybody who cannot answer that question, you're going to die of hunger. So let's go. You have a cake, and you subtract 3/4 of the cake. What's left? A quarter of the cake. So we're going to have what? A quarter of x, or just x over 4. So look at this one now. We have 2 cakes, and we are going to subtract 2/3 of a cake. What's left? So we have 2 cakes, and we are going to subtract 2/3 of a cake. What will be left? One and a third of, yes, 1 1/3 cake. It's easy. There you have your 2 cakes. Are they in the clear? Well, I think that you should be able to see them. Right? And we're going to take away what? 2/3. So what's left? We have 1 entire cake and 2/3 of a cake. Sorry, and 1/3. There it is. We can take a look and see. 1 entire cake is left, and 1/3 of the other. So students, when mathematics seem to be more and more difficult, we just go back to primary school. Yes, we just go to primary school. And it's just more fun. So of course you know what that is. X over 4 is right there, and then we're going to have 4 over 3. So x is equal to 16 over 3. Just eliminate this 4 by multiplication and we are done. Alright. Students, do not forget that I did, for classwork, the odd numbers. Right? Yes, we did the odd numbers. Let's go. We would have been maybe a little bit more through it if I remembered early. But no one remember, oh, Marcus Garvey. That's the G. Number 32. I like those two. We can get them out of the way very quickly. So number 32, I'm not going to argue with you. 6 over n is equal to 2. N is equal to what? Students, you have a problem like that? Don't show off your mathematical skills. Just show off your common sense. 6 divided by a number and the result is 2. That's all it's saying. 6 divided by a number and the result is 2. What is that number? As easy as that. Don't spend the entire night. 34. Eight over x is equal to 4 over 3. Students, do not show off your mathematical skills. Show off your common sense. All right, look at this one now, students. Look at this one now. You put 8 over a number. After putting 8 over the number, you cancel it down and you get 4 over 3. What is that number that should go here? You put 8 over a number, and when you cancel it down, you get 4 over 3. What's that number? Somebody say 6. Of course, x is equal to 6. Don't show the whole world that you can transpose, students. Show the whole world that you're smart. If you put a 6 here, 2 into 8 is 4, and 2 into 6 is 3. 4 over 3. 6 is the number. Number 36. Your favorite. 1 over 2x plus 3 over 5x is equal to 11 over 10. What do you think that we should multiply by? You got that number of 6's right there. What do you think that we should multiply by? We need to multiply by something that will eliminate the 2, the 5, and the 10. And we need to multiply by something that will eliminate the x also. The person who wrote 2 there could not be serious. 10x. That person who wrote 10x is serious. Now, students, 2x into 10x, the x will cancel, and then 2 into 10 is 5. So all that will be there is 5. 5x into 10, the x's will cancel, and 5 into 10 is 2. The 10 will cancel and leave the x. Then you'd say the x times the 11. 11x. You neither 7 nor 11. They used to have a little proverb like that. Neither 7 nor 11. Of course, what we have here is 7 is equal to 11x. So what do we do? All we need to do is what? Divide 7 by 11. Don't waste 2 steps just to do that alone, students. Turn it around at the same time. X is equal to 7 over 11. Because we're going to divide by 11, and that's all there is to it. Shame on you and the new recruit. Number 38. So let us put it right here. I'm not afraid to put it right there. Number 38. Behaving as if it is going to be very wide on the board. R over 3 plus R minus 1 over 5 minus 3R over 10 is equal to 3/4. So what do we multiply by? Let me see if somebody will come up with the answer for me. What do we multiply by? Four. Because of the 4, 30 will not work because of the 4. So the person who put 30, you just know exactly what to put, yes. So the person who put the 60. Let's go. 3 into 60 is 20. 20R plus 5 into 60 is 12. 10 into 60 is 6. 6 threes. 4 into 60 is 15. 15 times 3 is 45. Well, I hope that one turns out to be very nice. More in hope than any real conviction. 20R plus 12R minus 12 minus 18R is equal to 45. That's nice. No, it's not going to turn out to be nice. Not at all. So what do we have here? We have putting all the R's together. Let us do it in one shot. Here we're going to have 32 minus 18. That should give us 14R. 32 here minus 18. And then we have 45 plus 12. Oh no. That's a disastrous answer. R is equal to 57 over 14. Finally, number 40. 7x plus, no, it's not 7x. 7 plus x over 4. 7 plus x over 4 is equal to x over 3. That's nice. We're going to multiply by 12. This solution may be simplified by the fact that we're just going to have one fraction on either side, so we don't have to use brackets. Let's go. 4 into 12, that's 3. 3 sevens, 21. Plus 3 times x is 3x. 3 into 12, that's 4. 4 times x is 4x. That's nice. I love this one. So 21 is on that side. 4x minus 3x will turn out to just be merely x. So x is equal to 21. Students, all, we have gone through everything that was left for you for your, what do we call it? Call it what we will. So let us call it your transposition tutorial. and what's left of the linear equations. We have done that. Now, we have seven problems to solve for quadratic equations. So let us just do the 7 of them right now. And it's not my fault. It's yours, because you should have remembered that we did the odd numbers. I'm working on your behalf. So if the 7 problems get a little bit squeezed up in this, then you will have to take a portion of the responsibility. So let me see if I can find where it is. 38. I'm not going to write it over for sure. For number 38, we have to multiply by a number. 3 should be able to go into it, 5 should be able to go into it, 10 should be able to go into it, and 4 should be able to go into it, all without a remainder. And that number is 60. 3 into 60 is 20. 20 times r is 20r. Then 5 into 60 is 12. And 12 is going to multiply r minus 1. There. Then 10 into 60 is 6. 6 3 is 18. Then 4 into 60 is 15. Then 3 times 15 is 45. Now, we have, let us go, this will go back. 12 times r is 12r. 12 times negative 1 is negative 12. And then this 18 will go back, and the 45 also. Then we are going to put all the r's together. So we're going to put the 20r, the 12r, and the negative 18r. The easiest way to do it is what? 20 minus 18 is 2. And we put the 2 with the 12, we get 14. The 45 is here, we need to eliminate the negative 12. So 45 plus 12, that will give us 57. And that's all there is to it. If we have 14r is equal to 57, then we'll divide both sides by 14. R minus 18r is 2r. So 20 minus 18 is 2 plus 12r. And I hope that 45 plus 12 is 57. All right, so we have 7 problems to solve for your quadratic equation. It will go over 8 o'clock, no doubt, but let's begin. Number 2, because we did the odd numbers already. Number 2, x squared minus 16 is equal to 0. Can anybody factorize that? Can anybody factorize that? Great. There you did. Can anybody factorize x squared minus 16? We're looking at that very quickly. If not, well, I'll go straight ahead. By the time I erase that from the board, I should see the factors there. So it should be what? X plus 4, x minus 4. Then x is equal to plus or minus 4 for our answer. Students, in our classwork, we did an entire exercise on how to write the answer down when you have it factorized. And not to mention the factorization, where we exhausted factorization, difference of two squares, trinomial, factorization by grouping, basic factorization. What do we say about that one? 5x squared minus 80 is equal to 0. Nothing? Alright, the first approach that I will take is to take out a common factor of 5. Solve by analogy, students, because after taking out the common factor of 5, you get back the same thing here, x squared minus 16, just like that. So of course, the 5 will remain, then we have x plus 4, x minus 4 is equal to 0. And then of course, x is equal to plus or minus 4. And maybe you want to take another approach, which you divide the entire equation by 5, like we did in the classwork. Students, you are the ones forgetting the wonderful time that you had in factorizing all of those expressions. X squared plus 9x plus 20 equals 0. So my question to you is, what are the factors? The two numbers have a product of 20 and a sum of 9. They have a product of 20 and a sum of 9. What are those two numbers? The two numbers have a product of 20 and a sum of 9. 5 and 4. That's nice. X plus 5, x plus 4. So what is x equal to? Let me have it. If so be the case, x is equal to, for students who have been doing what? No, not students who have been doing nothing. Students who have been doing what? Of course, if you want to say 5 and 4, 4 and 5. So what would be the result? Of course, if x plus 5 is equal to 0, x is equal to negative 5, and so on. So we have what? X is equal to negative 5, negative 4. Number 7. Not number 7, number 8. I like this one. This is a model problem, students. That's a model problem. Number 8. It's very nice. X squared plus x minus 72 equals 0. X squared plus x minus 72 is equal to 0. What are the factors? They have a product of negative 72. They have a sum. They have a product of negative 72 and a sum of 1. A product of negative 72 and a sum of 1. What are those two numbers? Nine and negative 8 is correct. X plus 9, x minus 8. What should we write for the result? X is equal to what? Or what? X is equal to what? Or what? X is equal to what? Negative 9 or 8? I'm going to put the 8 first because the slot is small. Negative 9. Lovely. That's nice. We have gone through the most part of it. Oh no. Number 10 is armed and dangerous. Right, so right below that line, I may put number 10. It's a disaster. 9x plus 28 is equal to 9x squared. No, that's not it. Number 10. 14q squared. 14q squared is equal to 29q minus 12. So we have what? 14q squared. We are going to transpose a negative 29q, a positive 12 equals 0. Let us do our little primary school something. Let's do it. 12, 2, 6, 2, 3, 3, 1. 14, 2, 7, 7, 1. So, we're going to put them in numerical order. 2, 2, 2, then 3, 7. 2 times 2 times 2 times 3 times 7. So there you go. 2 times 2 times 2 times 3 times 7. What will give you the negative 29? What combination? Do not put in another number. Do not remove another number. Use all of these. It's a giveaway. Trust me. As long as I see it, I know the answer. It's a giveaway, students. It's a giveaway. What combination will give you the negative 29? It's a giveaway. I don't need to even know. I don't need to know that the product is 168. That's not relevant. What's relevant is the two numbers that you'll take from the combination here to give you the negative 29. Because what we should really have is this. 14q squared something and then plus 12. Plus 12 equals 0. What are the two? Because we are factorizing by grouping, what two numbers should go inside here? As I said, it's a giveaway. What are the two numbers to form the two new coefficients? What this tells me is that no one has been practicing. No one did the homework. That's nice, man. That's nice. Okay. We can choose any combination here. But what is evident is that we have an odd number here. Because we have an odd number here, it is the sum of an odd number and an even number. So the only way that we can get the numbers together odd, that's what we need. We need the sum to be odd. For a sum to be odd, one of the numbers must be odd and the other even. And there's only one way we can get it from there. Well, two ways we could get it from there. Only two ways. But the first one is evident. So it's going to be 3 7s 21 and 2 times 2 times 2 8. So it's 821. So we're going to have what? Minus 8q minus 21q. And what do we do now? We factorize. What's common in 14 and 8? What's common in q squared and q? It's just merely 2. So 2q is the common factor there. 2q is the common factor. What do we have? 2 into 14 is 7. So 7q here minus 2 into 8 is 4, and the q will cancel. Negative sign. Students, don't behave as if we haven't done myriads of factorization by grouping. So what do we have? What's common in 21 and 12? That's 3. So 3 into 21, that's 7. Negative into positive is negative, and 3 into 12 is 4. And of course, that is equal to 0. It's right. What I've done so far is correct. But I'm going to cause it to be a little bit more visible. Is it 21? $12. So our common factor is 7q minus 4, and the other factor is 2q minus 3. Don't tell me that you cannot see it now. So let me write this next cause it to look like 7q. 7q. Right. So what is the result? Anybody can tell me what q is equal to? Q is equal to? I'm hurrying to look on the board. No answer as yet. I'm not going to delay with my answer. I'm not going to delay with my answer. We first eliminate the 4 by addition, and then we divide by 7. 4 over 7. Then we eliminate the 3 by addition, then we divide by 2. 3 over 2. So let's bear it out, students. We only have 2 left. Only 2 to do. So number 12. What What do we say about number 12? Dear favorite, x squared minus 3x equals 0. X squared minus 3x is equal to 0. And what do we know that we are doing? Taking a common factor of x. So it's x minus 3 is equal to 0. So what is x equal to? Tell me what x is equal to right while I write number 14. Nothing? I was hoping that it'd be something. Alright. 0, 3. Fine. 0 and of course 3. Now, of course, let's go. 4 times negative 3 is negative 12. The product is negative 12 and the sum is negative 4. What are those two numbers? The product is negative 12 and the sum is negative 4. The product is negative 12 and the sum is negative 4. What are those two numbers? Just in case the brains are shut down, negative 6a plus 2a. And what's common in the first two? 2a. 2 into 4 is 2. A into a squared is a. 2 into 6 is 3, and the a's will cancel. A positive sign. There's nothing that we see here that is common, so let us use 1 for a common factor. 2a minus 3 equals 0. So what do we say now? 2a minus 3 is one common factor, and the other one is 2a plus 1. Finally, when I get the answers for the values of a, then the tutorial is over. Let's go. Yes. When we get the answers for the value of a, then that will be the last thing in the tutorial. 1 and 3, no. Not 1 and 3. One of them is 3 over 2, and what's the other one? A half. Oh, yes. Not quite. So we eliminate the 3 by addition and then divide by 2. 3 over 2. And the other one is what? Yes, negative a half. Negative a half. Finally. Okay, so it is not bad to finish up the solutions of all of your homework for the longest while. You know, for the longest while we haven't had a complete Sunday class. Today we have it, so we have to give thanks. And of course it has been very interesting, and what would say, yeah, it's been interesting, and we had the communication right through from the beginning, thanks to you. So at this point, I want to say a big thank you to all who made it possible. Yes, a big thank you to all who made it possible. So we have new followers, we have traditional members, the loyalists who are always here, the ones who are always commenting. We have everything nicely put together. We had heavy rain, and somehow the internet seemed to go down to be a little bit disadvantageous when we have heavy rain. We haven't had any glitch this evening at all concerning the weather and the internet. So we have to give thanks for that. And believe me, those crazy people, they don't stop driving and being on their phone. Can you believe, while I was coming down just now for class, somebody is driving fully on my side, approaching me fully. I wonder if my lights were on and bright. It was not yet completely dark. It was not yet dark. And this person is just coming head on to me, head on, in the rain. My lights are on, and all, with less than a second and a half left, the person swerved. They don't try to do that to me. They try to do that to themselves. Because they do that under the wrong set of circumstance, they will not make it out alive because of this God-forsaken phone. But give thanks to the Father above, I was able to make it. So thank you all for sharing. Thank you all for commenting. Thank you all for liking, for joining, everything that you have done to make this possible. And we will meet again tomorrow when we will continue with the solution of the solution of simultaneous equations. And if we cooperate fully, then this algebra book will be completed by Thursday. Yay! All right, yes, it will be completed by Thursday, this algebra book. And of course, we will move. I'll show you the next instructional manual that we'll go to. So when you see the hands go up, then you know that we are out. So, yes, have a good evening, have a good rest of the night, and see you again tomorrow evening for instructional class on Monday. Okay.